is Amira Musa, and I will be your session coordinator for today. So, moving on, our topic today is going to be about data policy, strategy, building an intelligent business and monetization. I would like to welcome our first guest speaker today, Mr. Michael Katz, CEO and founder of Deep Sea Solutions and Integrated Development Solutions, presenting his topic on SWAC for data center cooling.
Good morning, everyone. Oh, boy.
A resource that in Oman, we have a coastline with accessibility to deep ocean water that no one has in this region. What deep ocean water is water that in the sea, in the water column, where as you go deeper, 300, 500, 800 to 1,000 meters, the water gets much colder. So at 1,000 meters in Oman, it is between 6 and 7 degrees C. And even at 500 meters, it's 15 degrees. So we have this resource that along the coastline in front of Kalhat, in front of Masira, and in Dhofar region, even in front of Muscat, Matra Harbor. It is within an economical zone where it's financially viable to actually access this water and bring it to use in many different processes. The water basically is 2,000-year-old water. It's coming from the deep ocean, and it actually, the Harif season in Dhofar region is created by these deep ocean water currents upwelling. Basically, if you look at the bathymetry in the Dhofar region, and especially in places like Sada, even 600 meters offshore, it drops 2,000 meters. So if you imagine these deep sea currents coming and slamming in and coming and upwelling, that's what we have as a harif. Now, my company and partners, we have spent actually more than 10 years on trying to develop deep ocean water in Oman. And in 2015, at the request of the government, we did actual testing because they wanted proof that this water existed. Now, what you see here on the right is what's called rosettes and Niskin devices. These instruments we drop down off of a large barge, and we test the water from surface, 300, 600, 800, and 1,000 meters, and we take actual samples of the water. And of course, it was determined that, yes, we were absolutely right. Now, there's other characteristics of this water as well. When you get 500 meters below, you get into what's called SPF water. And SPF water, specific pathogen-free, it's pure, it doesn't have anything in it, and it is what's called, it's deoxygenated water. So if you take surface water at, say, 62 to 70% dissolved oxygen, even at 500 meters in front of Kalhat, it's only 4%. So what this means is nothing grows in this water. So when all of our issues with seawater intakes, with the desal plants, with the power plants, with Oman LNG, with processing, all have huge problems with biofouling. And they also have problems with everything from jellyfish to other things that really will close down the whole plant. And in fact, you know, if you look at Oman LNG, every day that they have to shut down costs them per train $1 million. So if we can help them, to improve the efficiency and access even 500-meter water, we can reduce their biofouling by 90%. These are the locations that we've identified as commercially viable, meaning that deep ocean water is close enough to the shoreline to be accessed economically. We now have technologies in Oman which we can expedite locally. We don't need, imported technology or anything else. We have the materials, we have the ability to actually do our own seawater intake systems. This is a graphic showing all of the different applications for deep ocean water, and I'm going to focus on our topic today of data centers, but just to give you an idea, and by the way, I'll mention it now, if anybody wants this presentation, I'm sure the organizers will be able to get it to you. This is what we have planned in 2014. This is basically an eco park, industrial park, but running on deep ocean water that includes data centers at the center, but also includes aquaculture, algae production, and greenhouses, and of course, solar and wind power generation. This is not new. In Hawaii, the Nala facility is a facility like this. Even though they don't have data centers, they have, I think, at Plaza, 50 or 60 businesses running off of the deep ocean water. And it brings, in 2016, it was bringing in $100 million into the Hawaiian government in tax revenue. So this is something that is not only viable, but it can be very profitable for the project developers. And of course for the government. Another aspect in the aquaculture, of course, developing aquaculture on land, they don't have to put in their own seawater intake system, so they can reduce their cost. This basically is just another diagram. Some interesting facts that a lot of people don't realize about data centers and the cooling. It's not a low temperature that is the sweet spot for cooling in data centers. It's 70 to 75 degrees, 21 to 24 degrees. So, and anything, less than that is considered wasting money. And there's 5 key challenges to data center environment control: adaptability and scalability, availability, life cycle costs, maintenance and serviceability, and manageability. And the metric that we use in data centers is power usage effectiveness. Now the thing with deep ocean water is, once you've put it in place, there's very little maintenance because there's no moving parts. And even the pumps to bring the water, which isn't a large capacity pump, because when you take water from 1,000 meters, at 1,000 meters in the ocean, it's 100 bar pressure. So you just need to bring it up in a siphon effect. And what we're looking at to actually maximize the opportunity for net zero is using tidal wave generated power, as well as OTEC, to run the pumps, so that even that is covered. Estimates are that between 70% to 80% of the cost of cooling can be reduced by deep ocean water. When you consider the chillers and cooling towers, and of course, it's also the use of water. Cooling takes a lot of water. Now, there's various means of cooling within the data center itself. Now we are looking at several different approaches, not only to the cooling of the environment, but also the cooling of the processors. There's immersive cooling, there's other coolings, even to the memory centers and the racks themselves. What we are looking at now, which is believed to be a new metric that is more effective, is the total power usage effectiveness. And again, rather than, yes, we all can put lots of solar, we can put lots of wind, why not reduce the power requirement itself? Because the biggest power requirement we have, of course, is the cooling. And these are the unconventional, this is, actually it's being used today, most of these in different ways, but we are still working with old technologies in the existing data centers. The reason is that we are now finding that because of the increased power requirements and the chipsets that are far more powerful, we are requiring better methodologies to keep these facilities cool and keep them operating. This is just another list of all the different characteristics, applications for deep ocean water. This is basically, again, a drawing showing how we can reduce our cost. This is also how the processing matrix works. I won't go into the details. And this is also on the left, that's the Natural Energy Laboratory of Hawaii. This has 3 deep ocean water pipes, as I mentioned before. This is Toronto. This takes lake water and is cooling the major stadium. And as it said, it does over 100 billion buildings. It's also currently being expanded. This just is a metric on how it explains it. This is Vancouver, my hometown. And this is where cooling from the inlet, because Vancouver's on the sea, and the convention center and I think 15 buildings are all being cooled in this way. Matra Harbor. We could make this redevelopment of Matra Harbor a net zero development with deep ocean water. If you take into account a 1.2 meter seawater intake pipe at 7 degrees will give you 40 megawatts of cooling power, which translates to about 6,000 tons. Again, this is how it works, but my idea also would be we could locate data centers in the ground floors or the basements of buildings where they are actually being used. This is just a drawing of, it's about 12 kilometers, but again, it's financially viable. This is a resort development to be complete net zero. In Tahiti, in Bora Bora, the first hotel using deep ocean water for cooling was the Intercon in 2006. Now there are 8 hotels that are all using deep ocean water. 90% cost saving. No more power bills. And this is just, sorry, I'll go back. The other aspect of deep ocean water is being able to do ocean thermal energy conversion, which is baseload power. What it is that you take deep ocean water up into a heat exchanger condenser, and you run a fluid through it, like, for instance, ammonia. When it hits that cold water, it condenses into a liquid. And as it's pumped, and you take the warm seawater from the surface water, so you've got 6-degree water condensing the ammonia, and then you have the heat exchanger with 26-degree surface water. The moment that ammonia hits the 26-degree water, it evaporates and expands into a gas. And that gas under pressure drives a turbine. And that's producing baseload power, 24/7, forever. The one thing that is the constant to keep in mind with deep ocean water, it is there, it's not going to change, it's there forever. And once you put that pipe, you have that source forever. That's my presentation. Anyway, I believe we have to use this resource. It is available to us. We have the technology. We have in Oman all of the technical expertise, as well as the materials, as well as everything to make this happen.
I mean, all these applications and projects you have mentioned in this presentation, just wanted to know what type of climate there, or the temperature of the places where these have been implemented.
Very similar to Oman. But keep in mind, I can give you one thing in particular. Not all countries have the access we do, being close to the shoreline. This is a benefit that we have. Now, everything from bottled deep ocean water, which is a billion-dollar industry in Asia, to utilizing now in Hainan, China, that they are going to do a 5-megawatt ocean thermal energy conversion test plant, as well as utilizing it for data centers, I understand as well. So it's not something that isn't being done all over the world in different places. Climate really doesn't, this is the big benefit we have, because we have that access where we need it most, which is most of our populations are along the coastlines.
Just to add to what our colleague has said here, is Dubai using this? All the 5-star hotels in Dubai using?
No. You see, again, we have it, nobody else in the Gulf has it. The GCC, the depth of the Arabian Sea is 88 meters at its deepest point.
Not even Neom, the line?
No, I mean, this is another phenomenon in the Red Sea, which should have been considered an opportunity, but in the research that was done, even in the middle of the Red Sea, which is 1,200 meters deep, the water temperature is static. It's the same as it is on the surface.
So it's a unique opportunity to Oman.
We have it, nobody else does. But that's the value proposition that we have, to me, is the fact that they don't have, we can be the lowest cost and, the most green, have that opportunity here. We have that here that none of the other countries have. And especially to me, the ability to execute with our own materials, technology, and expertise. We don't need anything else outside.
I have a question, Michael. So everything you said sounds really good and interesting, and I'm surprised that Oman has such a great opportunity to do this. Do you think it will happen?
Well, good question. because I've been working on this. I've given this presentation in 2014, so, but I don't give up. And I believe eventually, I mean, I've been in discussions with partners in the US and with some local people who actually coincidentally just mentioned a green data center for the Far region yesterday. And it turns out, of course, I gave them a presentation in 2016. So, you know, we need to get the government to be more supportive or behind resources that we actually have and are tangible, that require not a huge amount of investment to start to realize. And if we want to be at the forefront of digital technology, then we have to do this. And we have to be able to sit there and say, hey, this is the capacity we have in Oman. This is what makes us, you know, a competitive edge over anywhere else. This country is one of the 4th safest, best countries named in the world. We should be at that forefront. Thank you.
Yeah, thank you, Michael. This is very, very interesting. Looking into, so based on your assessment of the capabilities here in Oman, what's the maturity level that actually exists today, that it's either ready or semi-ready for, you know, these type of projects to build on it? And if we are not ready, how long it will take, or how much it will take, either of those two questions, in order to get there?
Well, you know, I have been in the Gulf a long time, and I have also actually designed and built seawater intake systems in Asia and in the Gulf. And, you know, we have companies here, and we have the materials manufactured here for the seawater intake pipes. The only thing that we would have to import would be things like pumps. But the bulk of the projects and the ability of people to execute, we have a pending project with Oman LNG to extend their seawater intake system with our companies, my partners, all local, everybody, even the material being made here to do it. So it's the only limiting factor is getting some backing by the government, and even some if they are like all of these. I've been dealing with the OIA and others. They want all these feasibility studies and all of this. We have all of this. We have it ready. We just need somebody to give a little nudge and a push.
All the best, Michael. I'm sure you're talking to the Supreme Council, to the ministry which is supporting the event.
Not yet.
Okay, I think that's
here?
something which we can help connect through the organizing team here. We can try to connect you to the Supreme Council for Planning and the ministry. This is a wonderful idea. It's a unique proposition and something Oman can be very proud of. So thank you so much for being here
We
today.
could be exporting this to Africa.
For sure, as an example, as a lead example. Yeah. Sure.
Thank you
All the
so
best.
much.
Thank you.
Thank you so much, Mr. Michael, for your informative speech.